A block of mass 12 kilograms is connected to a block of mass of 8 kilograms by a light, inextensible string which passes over a smooth fixed pulley. The 8 kilogram block is connected to a third block of mass 5 kilograms by another string as shown in the diagram. So we've got a 12 kilogram mass fixed over a light, smooth pulley, and the string is light and inextensible, i.e. it doesn't stretch, and then this 8 kilogram mass is then connected to a further 5 kilogram mass. Draw diagrams to show the forces acting on each of the three blocks, hence find the acceleration of the system and the tension in each string. So what we've got to do is find the tension here and here, which will be the same, and the tension here. Right, so drawing the diagram. So this is the whole system. So we'll take the 12 kilogram block. So in the 12 kilogram block, we've got the weight of 12g newtons acting downwards, and the tension, which we'll call T1. We'll call it T1 because we're going to have a second tension here. So T1 newtons, and we have this, because this weighs more than this side, the tendency will be to move this way. So the acceleration will be upwards here, so it'll be a meters per second. And then we'll take the 8 kilogram block, so we'll look at the forces on that. So we'll have the tension acting upwards here on that one. Okay, and we have the weight acting down, but also we'll have the tension of this piece of string here, which we'll call T2 newtons. Finally, of course, the acceleration there on this side will be acting downwards at a meters per second. Finally, we'll have the 5 kilogram mass with T2 newtons acting upwards, the tension here in the string, and its weight 5g newtons acting downwards. Right, now, of course, the acceleration also for that one, a meters per second acting downwards. So, writing down equations of motion. In the first case, we're going to have, because it's moving this way, so for the 12 kilogram weight, because it's moving this way, we're going to have T1 minus 12g is going to be equal to 12 times A. We'll call that equation 1. We're using Newton's second law here. In the third one, we're going to have 8g plus T2 minus T1 is equal to 8A, using Newton's second law. And in the third case, we're going to have the 5 kilogram one, we're going to have 5g minus T2 is equal to 5A. We'll call that equation 3. So we've got 3 equations, we now need to solve them. Right, so from 1, we can say that T1 is going to be 12g plus 12A. And then from 3, we can say that T2 is 5g minus 5A. Just pause the video if you're not sure about that. Now, if we substitute these two things in here for T2 and T1, we'll just get an equation in A. So, substituting into equation 2, we're going to have 8g plus 5g minus 5a minus, now be careful, put this in brackets, minus 12g plus 12a is equal to 8a. So we just substitute T2 here and T1 here. Okay, so we're going to write that equation out and then we're going to try to solve it. So writing it out in full, we've got 8g plus 5g minus 5a times 12g plus 12a is equal to 8a. Collecting up like terms, we're going to have 8a plus 5g, sorry, removing the bracket first, minus 12g minus 12a is equal to 8a. So we've got 8 plus 5 plus minus 12, which is going to give me g, and then we've got 5 plus minus 5 minus 12 gives minus 17a is equal to 8a. And then if we add 7 to both sides, 17a to both sides, we're going to get that g is equal to 25a. And therefore a will be g over 25, which is equal to 0.392 meters per second squared. Right, in order to find the tensions that we're asked to find as well, So if we go back into equation 1, which is T1 is equal to 12g plus 12a, that's going to be that 12g plus 12 times my answer to this part, which is g over 2.5. Using the fraction button on the calculator, g is 9.8. We're going to get 122.304, which gives me 122 newtons. Rounded off to 3 figures. In equation, substitute into equation 3, we've got T2 will be 5g minus 5a, which is 5g minus 5 times g over 25, which is 47.04, which is going to give me 47.0 newtons. So, drawing our diagram, we're going to have an acceleration of 0.32 meters per second, a tension of 122 newtons here, a tension of 122 newtons here, a tension of 47 newtons acting downwards, and a tension of 47 newtons acting upwards on this weight. Okay, so this has been a video to show you how to solve a pulley problem where on one side you've got two weights connected by a string. I hope you've understood, and I thank you very much for watching.